So we have learned integration by substitution, one of the methods. Now let's learn integration by parts, which is another method of integration. Now, when are we going to apply integration by parts, or what's the meaning of integration by parts? It's very simple. Integration by parts is the inverse of product rule. Okay, just like integration by substitution, which is the inverse of chain rule. Now we need to learn product rule. Let's go back to the knowledge of product rule. To really understand this, you need product rule. Okay, product rule is applied when you have functions multiplying themselves. You have two functions multiplying themselves. Let's say you have u and v. You want to differentiate it. So for this u and v, you want to differentiate it. You have d u v here. When you differentiate it, you are going to get this expression, which is called the product rule. You're going to have u dv plus v du. Okay. Now this is the differential form. Now let's say you want to get back your uv. What are you going to do? You have differentiate uv to get this expression. How are you going to get your uv? You integrate this expression. So you integrate both sides. So you now have integral form of d u v. They are together. Will give us integral form of whatever you do to the left hand side, you do it to the right hand side. U dv plus v du. You have them closed. Okay. Now you need to expand this. When you integrate this side, integrate it, you are going to get uv here is equals to integral u dv plus integral v du. Let's continue. The last thing that you need to do here is try to make one of these the subject of this expression. So let's do u. So which means integral form of u dv will give us what? uv, just carry this one to this side, minus integral form of v du. Even if you want to make integral form of v du, so the formula you have integral form of v du is still the same thing as what? uv minus integral form of dv. This is what is called integration by parts. Integration by parts. And when you are given function that are multiplying each other, what you just need to do is you pick one of these to solve your question. Listen attentively. Let's say you want to use this formula here. You want to use integral form of u dv is equals to uv minus integral form of v du. Listen once again. You make the first one. You can make the first one that is multiplying the second one. You can make it u. The second one will now be automatically dv. So you get u from your question. You get u and dv. Since you have gotten dv, you can now integrate to get your v. To get your du, you need to differentiate and you apply this formula. You can also make the second one u, while the first one dv. It depends on the nature of the question. You need to be smart as a student, because if you choose the wrong approach, you will keep on getting recurring integration by parts. Recurring integration by parts. Now let's see how to apply this to solve a question. Look at this expression very well. We are asked to simplify the integral form of x cos x. Now let's come over to this side. You have x, which is a polynomial function, which is a linear function. You have cos x, trigonometric function. X is multiplying cos x. You can use substitution method. What do you want to substitute for? If you use u, x is equals to u, abi? You have x cos u. Okay, you want to use cos x as u. Okay, x u. So it's not making sense. How do we now solve it? You use integration by part. Let's have the solution here, and let's have this thing divided into 2. You want to check something here. Okay, now we want to integrate x cos x dx. What we just need here is u and dv. We want to use u dv u and dv. Listen attentively once again. So if you make your u, let's just do it. Let u is equals to what? X. dv is equals to cos x. Here, if you like, let's say you now want to choose u is equals to cos x, dv is equals to x. Let's see what will happen. We are going to be solving them simultaneously, okay? And I want you to observe something here. That is why I'm saying you must be smart as a student. Know the easiest route to solving question. So u here. Now you have gotten u, so which means that our expression here has turned to what? U dv. Don't forget our formula will now be equals to what? uv minus, this one is u dv. So integral form of v dv. Go back to here. Oh yeah, this is what we want to use. So let's do this one first. You know u. What will be the u? The u, which is du dx, will give us 1 here. All right, dv is equals to cos x. How do you get your v? You will integrate. So when you integrate this guy, v, when you integrate cos x, you get what? Sine x. Okay, let's come over here. You've already gotten your u. When you differentiate this, the u will give us what? Minus sine x. Come over here. You've gotten your dv. To get your v, you integrate. When you integrate this, v will be what? X squared. Let us follow. We want to use this formula. U, integral form of u dv equals to uv minus integral form of v du. Let's just solve this one first. Oh yeah, let's just insert them inside this formula. Okay, so which means integral form of our expression here, which is this u dv, integral form of, what is u here? Cos x dv. So it's still the same thing, u dv. Yeah, don't let us write it. We give us uv. What is uv? X squared. This is v multiplied by uv. X squared cos x, that's uv, minus integral form of, what is v here? X squared. What is the u here? Multiplied by minus sine x. Then everything here with respect to what? The x. Now look at this. You still have, this one is, you are multiplying it, so you still have x squared, because minus will come outside here. This one will turn to plus here. This one will be cancelled. You now have x squared sine x dx. You still have something that are multiplying themselves again. So which means if you use this route, you are going to continue. It's not going to stop. It's going to be like a loop that you are continuing. It is going to be reoccurring, a loop that will not stop. But if you choose wisely, and because this one is x, anytime you differentiate it, it's going to be reducing by power. The power is going to be reducing. So even though if this one is x squared, it is better for me to choose it as u, because I'll be differentiating it. It means I'm going to use integration by part twice. If it is x cubed, I will still make x my u. It means that I will use my integration by parts how many times? 3 times. But because it is having just a power of 1, I will do it once. So it is safer for me to pick x as u here. That is what I'm saying. You see that when we pick cos x as u here, we are getting a reoccurring. Okay, let's now solve our question. Okay, du here is 1, v here is sine x. Let's substitute them inside this. So which means integral form of x cos x dx, which is u dv, will give us uv. What is uv? X multiplied by sine x. So we have x sine x minus integral form of v du. What is v? Sine x. What is du? 1. Can you see it? 1 times sine x. So you now have sine x dx. So you just integrate this, x sine x. When you integrate sine x, you get what? minus cos x. So this one returns to plus cos x and everything plus constant. You see that this one is not recurring. That is how to apply integration by parts. All this while we have been doing indefinite integral. Now let's do definite integral. Now what is definite integral? Definite integral is when you are given the upper limit, let's call it a, and the lower limit in your question and you want to solve it. Let's simplify this expression. What you see here is still the same thing as when you integrate this function f from 0 to a plus when you integrate this same function from b to 0. Listen attentively. Now this function here, which is 0b here, from b to 0, is still the same thing as minus this guy here, b to 0. Okay, so where you see function integral of b to 0, you can also have minus integral of 0 to b. So which means this expression here will now be what? Integral of a f 0 minus integral of b f 0. This is what you are going to do. Now, what I just did now is very simple. What you just need to do is you need to integrate your function, and the upper limit, you substitute it inside that function after you have integrated it. You now subtract it from the integral of the same function when you substitute the lower limit. That is how to solve definite integral question very quickly. Now let's see how to solve this. So which means evaluate integral of 1 to 0 x squared dx. This one is very straightforward solution to learn definite integral very fast. So what you just need to do is you do this integral from 1 0 x squared dx. So you have 1 0 outside here. You integrate this guy, is x squared dx. Okay, now when you integrate x squared, what are you going to have? So you have 1 0 that you later insert. You do it this way. When you integrate it, you are going to get x raised to the power 3 over 3. Now, when you are doing this plus constant, we can later on fizzle out the constant. Where you substitute the upper limit wherever you see x here. So you have 1 raised to the power 3 over 3 plus constant minus, you open another bracket. When you substitute 0 here, so you have 0 over 3 plus constant. So how do you now solve it? 1 over 3 plus constant minus 0 plus, so you have 1 over 3. So that's how to solve this type of question. Just insert and then simplify your expression.